Okie dokie. So, we're going to start off talking about the rock cycle. Now, we've talked a little bit about the rock cycle before. We've looked at some different kind of rocks, but we are going to look at the rock cycle a little more intensively. Some of you guys I know are finishing up Acuity. Some of you guys are done with Acuity and whatever. So I figured this is the best way to get this to you. So whenever you are done, you can get to this and listen to it instead of waiting on everybody to get finished and then wasting time. So let's jump into this right now. Rock cycle, pretty simple. You've got sedimentary rocks, you've got igneous rocks, you've got metamorphic rocks. Notice there's three types of rocks. Pretty simple. But how do they get to be those different types of rocks? Depends on how everything works in the cycle. So we know that everything has a cycle. Nitrogen has a cycle, carbon has a cycle, phosphorus has a cycle. Everything has a cycle. Rocks are the same way. So sedimentary rocks made of sediments. Durr. You've got igneous rocks, which when you think of igneous, I want you guys to think of volcanoes. And metamorphic rocks. When you think of metamorphic rocks, you think of the term metamorphosis, like Mighty Morphin Power Rangers, or the metamorphic properties, or the metamorphosis of a caterpillar turning into a butterfly. It's something completely different, something new. It metamorphosizes. So, again, three different types of rocks. So we look at sedimentary rocks. Sedimentary rocks are formed when particles are deposited and compressed. So you have sediments, which are like little pieces. Think of sand. There is something called sandstone, where literally you have small pieces of sand that have been deposited, which means moved together somehow, way, shape, or form, whether by wind, whether by water, whether by man, moved together. And so when they are together, over time they become compacted or compressed together. Big time, a lot of pressure. And when that happens, it fuses together and forms sedimentary rocks. Most of the rock you find around here are composed of sediments. It is sedimentary rock. Limestone is a sedimentary rock. Igneous rocks, like I said, when you think of igneous rocks, think of volcanoes formed by lava. Yeah, that's it. Igneous rocks are formed by lava. This is the youngest rock. So you have some magma or lava, and it cools somehow. And when it cools, it turns into igneous rock. There is igneous rock that can cool inside the ground or outside the ground, like when you see a volcano erupt, boom, there's a lava flowing. And when it cools, igneous rock. Simple as that. So there's internal and external igneous rock. Then you have metamorphic rock. Mighty Morphic Power Rangers or whatever it is. Metamorphic rock. Now, it turns into something completely different. That's what metamorphosis means. Turns from one form to something completely different. And it does that when sedimentary rock, this stuff up here, remember, formed from the sediments, fuses together, sandstone, limestone, eventually makes its way over time. It gets pushed down below deep. And when it does that, it has under an extreme amount of pressure. I mean, look at this. Sedimentary rock, great. You have the water, like Table Rock Lake. A lot of the sedimentary rocks formed by that pressure over time. But again, down here, look at all that. That's a lot of weight. And that's an extreme amount of pressure. And, of course, the lower you get down here, the warmer it is. So you take the heat and you take the pressure. And that, over time, makes metamorphic rock. Think of it this way. A diamond used to be coal. Yeah, used to just be a big old piece of carbon. But under extreme amount of pressure and heat, it turns coal into a diamond. So think of it that way. Coal and diamond, completely different things. Coal's not worth nothing. But a diamond, giddy up, it's worth a lot. So you have metamorphic rock, which is changed by heat and pressure. A little bit more detail on igneous rock. It's formed by magma, like we said. That's just molten rock, and it cools, and it becomes solid. It's kind of cool stuff. But the thing I want you to think about igneous rock is it's the quote-unquote youngest rock. It's the newest rock. Because eventually everything, part of the cycle, goes to where it can be hardened, and then eventually it can be compressed down here to where it goes into enough heat where it melts. And when it melts, eventually it will make its way back up, and it cools, igneous rock. They can form either below the surface as intrusive inside rocks or on the surface as extrusive or outside rocks. This magma can be made up of melted pre-existing rocks. Like I said, sedimentary rocks move their way down into metamorphic rock. Metamorphic rock can move even further down and eventually melt, gets turned into magma, which eventually will cool, then forming igneous rock. Simple. Made mostly up of interlocking crystals and usually very hard to break. And that is true. I mean, it's pretty solid. It's good stuff. Like, have you ever seen lava rock? Try breaking lava rock. Not that easy. Sedimentary rocks. Sedimentary rocks are easy. It's formed of sediments, little grains deposited by water, wind, ice, people, even, machines, whatever. But we see what happens when we have a big rainstorm, and we see all the things that get washed out. Like, for instance, my driveway. I hate when it rains really hard because I have to go out there and have to fix my driveway, which is made of a bunch of just pebbles and rocks and stuff. And it rains and washes out big old pits. And usually where I find all that rock is it's washed it down into the lowest part. Okay? So, it gets deposited. Okay? The grains are formed by the rocks eroding. Again, it moves all together, and eventually it can become layered. And when it becomes layered, it goes under pressure, and that pressure then causes it to solidify, become solid into something completely new. They're always formed in layers called beds or strata, and often contain fossils. Why? Is because something dies, and when it dies, it doesn't really move. It just lays there, and eventually becomes decomposed. Where what stays there? The bones. And so over time, things get weathered and eroded, and that sediment gets deposited by the water, wind, or ice on top of that dead thing, the bones, and then can create a fossil. Simple as that. Metamorphic rocks were once igneous or sedimentary rocks, but have been changed, metamorphosized. Metamorphic rock are changed by the intense heat and or pressure within the Earth's crust. Pressure, huge amount of pressure to take something like sedimentary rock and change it into something completely different, metamorphosized, which is and turns into metamorphic rock. It's crystalline and often have a squashed, which is, we're going to use some fancy terms, foliated or banded texture. You've seen rocks like this before, really. You can get marble. You guys have all seen marble. Marble used to be limestone. Crazy as that may sound, it used to be. So all that cheap limestone you see lying around outside Table Rock Lake, tons of limestone. Well, eventually, if under an extreme amount of pressure, it can turn into marble, and we all know marble can be worse than bank. If it's used, we use marble for, really fancy buildings. We use marble for, tile, for bathrooms, kitchens. You can have marble countertops. Marble. When you think of marbles, the game marbles with the little balls, and you push them with your fingers and you try to shoot them out if you've ever played marbles. I know I'm old. I have played marbles before. Marbles are not marble. They're not made out of marble. They're made out of glass, so don't get those confused. Like I said, everything has a process. Everything has a cycle. So you can look at this just like you could the water cycle or the phosphorus cycle or the nitrogen cycle, but this is basically it right here. We can start anywhere. Let's start just at the top. Why? Because it makes sense. So you have rock. So the surface rock that you see outside, eventually because of rain, wind, people moving it, becomes eroded. And it can be transported by the rain and wind or people and eventually becomes deposited. When it becomes deposited, that sediment can eventually be compacted under an extreme amount of pressure and turn into sedimentary rock. Yay! And eventually, if it gets pushed even lower, all that pressure from everything above it, whether it's water, whether it's land, whether it's dirt, whether it's other rock, eventually becomes metamorphosized or highly pressed and turns into something completely different. So think about it this way. You have something like sand deposits in here. Eventually, the sand can turn to sandstone. That sandstone eventually will move its way down, gets metamorphosized, turns into metamorphic rock. Or eventually, as the plates move and as the crust of our planet moves, it can go lower down deep within the earth where it becomes melted, and it can eventually turn into lava, magma if it's underneath the ground, lava if it's outside the ground, and there it goes. It's lava, or it can cool inside. Intrusive igneous rock, extrusive igneous rock. If it's extrusive, great. It can be weathered quickly and right away. If it's intrusive, eventually it can do what they call uplift, which is be pushed up by all this pressure of everything going. Mountain ranges. Mountain ranges are caused by uplift. You have two plates that push together, boom, boom, and eventually you can have these mountain ranges, and that's also where you can see all this magma being pushed up and eventually makes the volcanoes, like that little movie I showed you where he had a dream that he hoped would come true. And one day he was hoping to get that fine looking other volcano that he could lava to. So, yes. Weathering, it's a good term. Know it. Physical weathering. Physical weathering can be like freezing. If something freezes and thaws, it expands and contracts when it freezes, and when it does, it can crack and break. Simple as that. Chemical weathering. Now, chemical weathering, especially when we look at something like limestone or different kinds of clays or things that have salts in there, a reaction takes place. Ever heard of acid rain, especially when we talk about pollution in the air? Well, when that rain falls and hits the rock, it can weather it away. It can make that one solid rock, little pieces of it come off. It can weaken that rock, and that causes sediment. We call that chemical weathering. Then we have biological weathering. For instance, I'm just going to read it. Trees put down roots through the joints or cracks in there. We see it here, and eventually can break apart the rocks. Done. You know, if you take a piece of sandstone and rub your thumb on it a whole bunch of times, eventually you can wear it off too. So that's biological weathering. We have physical weathering, chemical weathering, biological weathering. Next slide. Erosion and transport. Erosion just means it gets taken off some way, shape, or form. And we can see this picture here. This has probably been caused, obviously it looks kind of like a desert, but I'm sure there's rain that has hit it over time. But a lot of wind has kind of eroded all the stuff away. And it can be a very serious environmental problem, just saying. But why? Because when it does occur, it takes soil away from it. Like I said, my driveway, it causes me a serious problem. Not just because I'm lazy, it's because I'm sick and tired of going out and fixing it when it erodes away. But it's just what it does. So, say like a dust storm. If you ever seen movies or whatever with these big old sandstorms or dust storms, think about that. That's a lot of depositing. Moving something from one place to a totally new place causes problems for both places. Then it says here, around the world, moving water picks up and transports millions of, it says it's tons. You like that spelling? But tons of sediment every day along rivers, coasts, and even in the deep oceans. Think about the Grand Canyon. I mean, that's a massive expanse, huge. And that was just done from the Colorado River, washing over that rock over and over and over and over again, making that huge canyon. Think about it that way. So rivers, lakes, streams, anywhere there's flowing water. We see that all the time. We can see where there's been sides of hills that have been washed away or mountains that have been kind of washed away, torn away just by moving water and wind. Pretty cool. Here's something for you. Deposition, burial, and compaction. I need a drink of my Diet Pepsi. It's killing me. But deposition is a layering down of sediment. Deposition is just a fancy term for saying deposited. Like you take money, you deposit it into your bank account, which means you take money and you add to the money you already have in your bank account. Unless you're like me, you just put it in there and it's like, oh, look, it's gone again. But normally, when you deposit money, what that means is that you just add money to the account. When you think of rocks and deposition, that just means that you take that rocks and you deposit them someplace else. And eventually, like you see in this picture, we see these different layers. So, you know, at one time, this was already here. This layer right here, it's a different color. Who knows what that's made of, what kind of rock or whatever. But all that was deposited, that sediment was deposited. And over time, as this was then deposited, and then this, and then so on and so forth, that weight has turned these other bottom layers into rock. They pile up on one another, and the sediments beneath are buried. It's crazy, but that's a lot of weight. It's ridiculous. So again, we're looking at the Grand Canyon. This is the Colorado River. Eventually, it's kind of washed its way down, but this was also made and built up by different layers and levels of sediment over time. So to put everything that we've talked about together, we've got this. Remember it. It's a cycle. Simple as that. And there's some fancy terms that you need to know. Erosion, transport, weathering, crystallization. That just kind of means hardening. Metamorphic, to change into something completely different. Sedimentary is conformed with sediment that was made by things that eroded and was transported and eventually compacted. Why? Because it was buried underneath all these things. So just take a look at this. Get familiar with it. It's just another cycle. So I was going to, and we probably will do, I had all these dates are jacked up because of us having to, take our acuity test. But eventually next week when we get back, I want us to look at and create our own version of the rock cycle. If you go online, there's tons